This question would be one of the last in an SAT no calculator section or calculator section. Either way, it doesn't really matter. The point is it's something that we would need to be careful of tricks, and it looks kind of tricky just based on the answer choices. But what I see here is that I'm going to be able to use one of my favorite strategies, plug points into equations. It's really obvious because the answer choices are all equations. And whenever I have a graph, I know that I have points, right? That's a collection of points. All of the line is the points that I could plug into equations. Now, there is a little bit of a twist here, but I do think that we can still use the very robotic nature of this strategy to help us through it. The equation that matches with this graph is a little weird. It's y equals f of x plus 2. But let's just very simply go through the plug points into equation strategy here. What would we do? Well, I'd first start with the simplest point, which in this case is the y-intercept. That's almost always going to be an easy point to start with because one of the numbers is 0 and it's usually very easy to see on the graph. So that's my point. I'm going to even write it out here. The point is 0, 3. Now plug points into equations. So that point is supposed to go into the equation that's written in the question, not the choices, in the question. So what do I know? Well, okay, y would be 3. X is 0, so I'm just going to not really think too hard about it. F of 0 is what I would write here because I replaced the x with the 0 plus 2. Now this may look weird to you, but I think most of us are going to have a little bit of a next step kind of just automatically come up. Let's subtract 2 from both sides, and we get that f of 0 is equal to 1. This is also a point. This is a slightly different point now that's going to apply to the f of x equations that are in the answer choices. So the graph is a modified version of one of those equations, so we're kind of working backwards from that modification to get back to the original equation. So what this is telling me now is that when x is 0, the f of x or the y is 1. So we would test that point in all of our answer choices and see what happens. Well, 2 to the 0 is 1, so that checks out. 3 to the 0 is also 1, so that checks out, and this happens a lot of times. 4 to the 0 is also 1, so we've got a little bit of a problem. But luckily, 4 to the 0 minus 1, well, that's 1 minus 1 is 0. This is not correct, right? We now can see choice D does not match with the graph because it's producing an invalid equation. 0 equals 1. That's wrong. So here, I'll even write it. So, okay, what do we do? Well, we plugged a point in and it got rid of one choice, so maybe if we plug in another point, it'll get rid of more choices. So that's where we'd go from here. So this time I would choose the next best point, which in this case is 1, 4. So let's just go right to here. Let's do it over here, 1, 4. And we do the same process. We plug that into the equation in the question first. So 4 is equal to f of 1 plus 2. We subtract 2 from both sides. We get 2 is equal to f of 1, which means now I have the point x is 1, y is 2, and now I can plug this point into the equations. So I go to choice A. 2 to the first is 2. That checks out. That looks good. And we can see 3 to the first is 3, 4 to the first is 4. So these two produce incorrect y values, leaving me with the one right answer, choice A, f of x is equal to 2 to the x. Do you really need to know beyond that what's going on in this question? No, I don't think so. This is why plug points into equation is such a powerful strategy, is it lets us be a little bit more robotic about things. This is a harder version of that because this is a harder question, but it becomes much easier because we're able to visualize what's going on with actual numbers, and that really is at the heart of most of our math strategies. Algebra is confusing when it's conceptual. It's much easier when we can turn it into arithmetic with real numbers. So try to do that as much as possible.